Welcome everyone. My name is Dzan Ta with Repro Products. Our presentation today is on how to create a project dashboard using Revit, Dynamo, and Excel. Our agenda will focus in on what is a dashboard and why use one, what are the elements of a dashboard, some examples, and then the actual demonstration of creating the dashboard using Revit, Dynamo, and Excel. So what is a dashboard and why do we need to use one? In essence, a dashboard is a visual tool. It gives us the ability to present large amounts of data in a clear, concise manner. It gives us the ability to measure performances, indicators. They're usually called KPIs. That information is typically displayed on a single screen and is usually interactive. Here are some examples of dashboards that have been created in the past. As you can see, they are clean, they are concise, they are colorful, they represent the data and display the data in a clean manner. So it's easy to understand and easily to very quickly get the understanding of the data automatically. So what are the elements of a dashboard? There are three elements of a dashboard. The first is the data source, and in our case, the Revit model. The second is the real-time connection to the data. And in our case, again, it will be Dynamo. And then the third element is how to visualize the data. And in our example, it will be through Excel. Some typical uses for dashboards is to display information such as information from a master plan, perhaps programming data or room area volume calculation information, or perhaps curtain panel types, and maybe even FF&E equipment. There are several other types of ideas and ways dashboards can be used, so I hope that after watching this program, you'll get an idea of how to use them, how to create them, and come up with your own unique dashboards. With that, let's jump into the software. So before I jump into Revit and the actual Revit model, I'd like to show to you the end result of the master plan dashboard that we're going to create. It's shown here in Excel, and as you can see, it gives us the information that we want to see for area by usage and building, total area by usage, and all the different names of the buildings and their areas as well. And with that, let's go ahead and jump over to Revit. So here I am in Revit 2016, and what you'll see is we have a few buildings that we've created. These are mass objects that are in place families. When I hover over one of them, you'll see what the name of the mass building is. And so I have several of them, 7 of them, and they have their mass floors created already. If I select a particular mass and we go to the instance property, you'll notice you'll have data such as gross floor area, gross surface area, and gross volume. We can also click Edit for mass floors to take a look and see what are all the mass floors that have been created and what levels they have been associated to. That data, gross floor area, surface area, and perhaps volume, as well as the actual name of the mass and the family type, is the data we actually want to pull out of Revit to assemble and to create our dashboard. The way we're going to do this is we're going to use Dynamo. If we head over to the Add-ins tab of the ribbon, there is a visual programming panel, and your Dynamo software is located here. Dynamo is a separate piece of software that you need to download and install. This software is by Autodesk. It is open source and is actually evolving very quickly. And it seems as though there's a new version of Dynamo every week or every 2 weeks. If you want to get to the website to download Dynamo, we'll just head over to Internet Explorer. You can type in BIM Dynamo. It's the easiest way to do it. And it'll take you to Dynamo's website. You can click download, and it'll take us to the download location. Once you have specified which ones you want to work with, the Dynamo version that we're working with here is the free version, and they do have a Dynamo Studio version which costs money. For the purposes of the webinar, we're going to use the Dynamo one. I already have it downloaded, and as you can see, it's in the Add-ins tab under Visual Programming. I'll start the command, and what ends up happening is that Dynamo starts up. When Dynamo starts up, it takes a look at the existing Revit file that you're in and creates a direct link between that particular file and your session of Dynamo. What does that mean? What that means is that when you're working within Dynamo, any type of visual programming tool or creation that you make is directly linked to this particular Revit model. So any set of instructions that you create and run will automatically run and execute within Revit as well to give you the generated data that you need. For those of you who are not aware of what Dynamo is, in essence, it is a visual tool to help you create and work with the Revit API. In other words, you're starting to do programming with Revit. It's a great tool because for those of us who are not programmers or who don't have say a computer science degree background and are not into programming languages, this is a great tool to use because it gives us an easy way to build relationships from one object to another or one set of instructions to another. And that's the essence of Dynamo. So I'm going to click New and start a new one. I'll expand the display, and you can see we have a work plane that displays just for the sense of understanding visually where we are. On the left-hand side, there is a list of tools for us to pick and choose from, and as you can expand each one, you'll see the different types of commands that you can initiate and use. There's a very handy search feature here as well. And so what our objective is within Dynamo is to create what are known as nodes and build several nodes and connect them together so they form a logical relationship from one side to the other. For example, if I go inside the search field, I'll do a search for categories. I'll click categories, and you'll notice that that node pops up. Now, if we take a careful look at the understanding of what a node is, it is typically a box. The dark gray area lists the name of the node that you're working with, and then there is a left side and a right side. The left side is the input. The right side is the output. So you can tell the software when you're plugging nodes in, you can link from one node to another node so it knows what to do. For example, here for categories, we're looking for mass floors, and it's alphabetical, so I can click mass floors. And you'll also notice that there is a little white window that will display the results of any execution that occurs for that particular node. We want to tell the software that we need to pull the mass floor category of these objects. So I'm going to go back into the search condition and use another node called elements of categories. And now another node pops up. We can then go ahead and link the category to this category. Now, depending on what version of Dynamo you are running, you may see the results pop up automatically, you may not. For what we are trying to do for pulling out this data, we need to pull several bits of information. We need to pull information such as the level, the floor area, the usage, the mass family and type, and the exterior surface area. So if we tell the software we want to get the parametric value of that particular element, for example, levels, it will pull that data. So again, we can go into the search field and type in for another node, element get parameter value by name, and it will automatically display that node. We want to tell the software that this particular element is being pulled out. The parametric name that we want is going to be the level. When you are creating a special node that is specific for just what you want, that's called a code block. You can double click anywhere you want in the working area, and a code block dialog box will pop up, and your code goes in there. The way this is written is you use quotes to bracket the name of your particular parametric name. If you need to create more than one, you can separate it with a semicolon. So for our purposes, we want several. We want floor area, level, usage, mass, don't forget your quotes, family, mass, family, and type, and then lastly, exterior surface area. And when you're finished, if you click out into space, that code block will be created. As you can see, we have code block information to describe and pull these particular parameters. We can link the first one for level to that parametric name. And as you can see, the end result is a list of all the levels that it found for all the mass floors that are available. We want to go through the process of creating additional element get parametric value by name nodes, one for each of these. You can just select it. You can use Control C and Control V to copy and paste. To disconnect the wiring from one node to another, I can just click out and click into space. So the second one we want is floor area, and now that data shows up. So let's go through the process of creating some more. Also, as you're creating your Dynamo script, you want to try to keep things clean and orderly as you can, because over time, things will get very convoluted and twisted. So let's go ahead and build some more. And then we have one last one to do. By the way, in regards to navigating, you can use your scroll wheel just like you do in any of the other Autodesk products to scroll towards you or away from you to zoom in and out. There are actually two interfaces that you're working with. The first interface is the front end interface, where you're applying all the nodes and all the wiring. The other is the background area here, which you can click this icon to jump between a 3D background preview to the graphics view. So if I click this one, you're going to notice that the nodes disappear, and now I can zoom in and out and pan with the other space. If I click this one, it jumps me back to this view. So now that we have all of the information being pulled out, we need to assemble this data into a list. For example, we can tell the software to create another node called a list create node. We'll place that here, and we'll tell the software to pull all the data for each one of those items and display it in a master list. As we work with the list create node, we don't actually have to create multiple nodes for each one of these elements. We can actually hit this plus symbol here and create as many nodes within that as we need. If you notice very carefully within the list create node, there's actually items 0 through 5. In most programming languages, the first item that you're trying to pull doesn't actually start with 1. It actually starts with 0. Since there are 6 parameters that we are trying to pull out of the Revit model, there is going to be in our list create 0 through 5 items. We can then now tell the software to pull that data out for each one of those items, like so. So again, we are connecting the output of one node into the input of another node. In doing so, our list is created. In Dynamo, by the way, in the lower left-hand corner, what you'll notice is that you have a button for automatic. What this means is that the script, the set of instructions that you're building, are actually ran automatically. If you need to, you could specify manual, and therefore it will not run until you actually click run. So now that we have our list created, what you'll notice is that this list is just a list of everything. It's a collection of lists, if you will. We don't typically look at this kind of data in Excel in this aggregated format. What we need to do is we need to sort this information and display it a certain way. Before we do that, there is a specific node that you can use called watch. What this node allows you to do is to tell the software, display the information for me. And the way that functions is it displays the information once the script is ran, and it stays open so you can see the data. Without this watch node, we would have to go over here to the list create node and let it expand for us. But as we move our mouse away, that list disappears. Like I said earlier, we need to take this information and sort it a little bit better. There is a node that's called list transpose. That you can use, and it basically sorts the information. So the way this one works is we'll click the list, create list here, apply it to the list transpose, and then we'll use another watch tool to connect this to here, and then we'll run. And now you can see the difference between the first list and the second list. The first list just gives all of our lists in one single order, whereas the list transpose node gave us the ability to sort the data a little bit easier to work with. So now that we have all of the lists set up the way we'd like, we need to actually pull this information out to display it. So like I said earlier, the three elements of a dashboard are the data source, which is the Revit model, the live linking tool for the communication back and forth, which is this Dynamo script that we're creating, and then the visual display of the data, which is Excel. So we can head over here back to the search, and we can do a search for Excel, write to file. It will pull up this node, and we can start to input the data that we need for each one of these elements. Obviously the path and the file name for where we want to write it, the name of the sheet, where does the data start to display for the row and the column, and the actual data that's being inputted into that Excel file. We also have the overwrite feature here to give us the ability to overwrite any data if we have to. So the first is the file path. Let's just do a search for file path. There we go. Click it, and we have the file path command. We can link this to the first, and we want to go ahead and click Browse, and I'll specify temp folder, Revit Dashboard Tutorials, and we'll give it a name. And I'll call it Master Plan Data. We also need to specify the name of the sheet, which we'll just use a code block, and we'll call it Floor Data. We also need another code block to specify the start and for the row and the start for the column. So I'll just use 0. So now I can click and link the floor data to the sheet name and the 0 to the start row and the start column. The data is going to be coming from our list creation tool that we made earlier from the list transpose. So I'll go over here to the create list and the list transpose that we see and use this to connect to the data. Since I still have it on manual, I have to click run and let it run. What ends up happening is that the Excel file is created automatically. That's called masterplan_data. And you can see we have the level data pulled out. We have all the information for the floor area, the usage, the mass family and type, and the surface area. What you'll also notice is that we actually don't have any headers for this particular Excel file. There are several ways we can approach putting in these headers. We can either do it manually, which a lot of people do, or we can actually continue to use Dynamo script to correct this issue. So I'm going to close this file. And now we want to introduce code blocking and another list creation node to specify those headers. I'll go ahead and double click, say over here, and I'll start putting in the code blocks for the headers, for the type, for the building, for the level, for the usage, for the area, and for the external surface as well. Click out into space, and our code block is created. We now have to use another list create tool, so I can actually use this to say Control-C, Control-V, move this over here, disconnect these, because I don't need those, and then use our connectors for the code block we made earlier for each of the items. Now that we have the code block and the list create node created, we actually have to use another node to tell the software to apply this data to the very front of our list to begin with. So again, in the search field, we can type for a specific node called list add item to front. And there's that node. We'll go ahead and tell the software to take this list, create node, and those particular headers and assign them to that item. We then need to take our list input here and associate it to the list transpose from the original, which is here. The data is no longer going to be from the list transpose, so we're going to have to remove that. And now the list from list add item to front is actually going to be connected to our data. So like I said earlier, when you're working with Dynamo, things are going to get very hectic and convoluted, especially with all these wires. So try to be as clean and concise with your placement of objects as you can. So the good thing is that it's very easy to click and drag and move things about the way you need. Like so. So if I place my mouse over the Excel right to file, we can still see all the data. Since I have it set to manual, I still have to click run, and now it will create the Excel file with the headers. That is the Excel file of all the data that has been pushed out, and now we can use this information to create our dashboard. So now that we have our raw data out of Dynamo and into an Excel file format, our objective is to create the dashboard, if you will, of this data. Now, the easiest way to approach this and the better way to approach this long term is that the dashboard that you create it as a separate Excel file. And the logic is this. The pivot tables can pull the data from multiple data stream connections, if you will. If you keep that dashboard as a separate file, you can reuse that file for other types of data from other either Dynamo scripts that you've created or other Revit projects that you're working with. So I'm going to go ahead and create a brand new Excel file, and then we'll head over to the Insert tab. In the Insert tab, there is the Tables panel and the Pivot Table command. I'll start that command. And here you can either specify a table or a range, or in our case, using an external data source. I'll click Choose Connection and then browse for the one that we need. So I'll head over to my temp folder, to the Revit Dashboard Tutorial folder that we've been working in, and I'll pick the Master Plan Data XLSX file that we just created. I'll click Open, click OK, and then place it by clicking OK. That pivot table is going to give us a little white box, and then on the right hand side you have the pivot table field list that displays all the different types of objects and data that it pulled from the prior Excel file that we made. I can go ahead and tell the software to input things such as the area, the building, the level, and maybe even the usage. We can also, down here in the lower quadrant, drag fields and move them about. So for example, we don't want that over there. We want area over here. And instead of count, I can go into the settings and specify, say, sum. So you can see we're starting to get data that displays building level, usage, and sum of area. So when we're working with the pivot table, we can actually sort in different methods. We can sort, for example, by usage, and then by level, building, and then by level. And you can start to see that the data on the left-hand side displays and changes that information for us. Now, if you notice very carefully, the information that's being displayed in our Excel file is not correct. For example, you'll see sum of area and it shows zeros. What is happening here? What's happening is the mapping of the information is not correct. So let's go ahead and fix this. So here I am back in Dynamo, and what's occurring in our Excel file that shows misinformation is the linking and the order of our title block information here and the element parametric information that's being pulled out here. The code block data, the sorting is not correct. We want the type, which is really going to be mass, family, and type, to be connected to the first node. We want the building, which is going to be the family, mass, as the second. The third is our level. The fourth is our usage. The fifth is our area. And then last is our exterior surface. So just to be sure, you can kind of pull this out a little bit and follow the lines to ensure that's exactly where you need them to be. So the first one we said was the type, which is mass, family, and type. And you can follow that node and you'll see it be the first one. Mass family is the building. And follow that node, that's the second data. So here's item 0, type, item 0, item 1, building, item 1. The third is item 2. Remember, we're starting with 0, not 1. So the third item is actually item 2. And that information is the level. Usage is the next one, which is item 3. Item 3, follow it across and verify it's going to usage. And then the other two are functioning properly. Now if I click run, the data is going to be created. We'll head over to our Excel file again and start a new pivot table again. So we'll start a new Excel file, insert tab, pivot table, use an external data source, browse for the one that we want, master data plan, hit open. Using the floor data, hit OK, hit OK. The table shows up, it's blank, and we can specify area, building, level, and usage. So again, we're going to sort by usage, then by building, then by level. And sum of area is still holding. So you can see over here, our data is being sorted properly now, and the information is displaying properly. The next step is to actually tell the software, create the graphical aspect of the pivot table. So now that we have our pivot table data, we can actually make it a little bit more interactive by making sure that we have our cursor inside that pivot table area. And under the Options tab, there's an Insert Slicer command. If I do this, I can say, let's put a slicer in by usage and hit OK. That usage is placed here. And if I click Amenities, it's going to just sort the data just by those particular uses. If I click this icon here, it will clear the filter and give that data back. On the right-hand side of the Excel file, it looks like our choices for the pivot table data is missing. If we click inside our pivot table raw data, that pivot table field list will show back up. Let's go ahead and create the graphical aspect of the pivot table. So now let's head over to working with creating the pie charts, if you will. We head over to the Insert tab. We can choose the information that we need. There is a contextual tab called Pivot Table Tools that if you select, you'll get to the Tools panel, and in there is your Pivot Chart command. Click it. It'll open up the Insert Chart window, and we can say, let's do, say, pie, for example, and click OK. That data is going to show up. It's going to be displayed. We can graphically move it about. And if I click, for example, any one of the usage filters, you can see that the sum of area pie chart will change and display that data. So now that we have our pie chart for the sum of area for total, how do we go about creating other pie charts that display other data? I'm going to go ahead and move things around a little bit. And we can just go through the same process on another sheet to insert another pivot table using the external data source that we created earlier. And if you're not sure of the naming convention, because you might have more than one, you can again just click Browse and head over to the file that you were working with earlier. Click OK and go through the same process. This time I'm going to say, let's create one based upon usage and area. Now that that data is displayed here, we'll go to Pivot Chart and specify another pie, hit OK, and that information shows up. We can click inside here and say total by usage. We could take this, Control-C, copy it to the clipboard, go back to sheet 1, Control-V, and paste it. And so if we click inside, we can see that information as well is updated. So let's say we want to create one more pie chart that defines the number of levels there are in each of the buildings. Let's go ahead over to the next sheet that's blank and create another pivot table using the same external data source. And again, if you're not sure, go ahead and use Browse for more again and pick your particular file that you're working with. Your blank pivot table shows up as before, and this time we want building and level. The level we do want to sort, and we want to sort by count. So you can see we have buildings 1 through 7 and how many levels each one has. Let's go ahead and create a pivot chart. And we'll do the stat column in this particular situation to display levels per building. And now you have a pie chart for just that. Again, I'll use Control-C to copy to the clipboard, and then I'll Control-V to place it where I want. Lastly, you can rename your tab that says Sheet 1 and call it Dashboard. The last thing we want to focus in on when we create our digital dashboard is the graphical display representation of the dashboard. So let's go ahead and insert some rows and columns so that we can create some space and control that spacing. We can also go to the View tab of the ribbon and turn off the grid lines, and then we can move our pie charts like so. Now, when we are working with the pivot chart, we want to ensure that what we have is sound. So let's go ahead and head back to Revit for now. So here I am in Revit, and let's say, for example, I want to make some design changes that is going to affect the overall number of floors, the mass floor areas, actually the quantity of the buildings if we need to, or any type of change that's going to affect that data. So let's see, let's go ahead and select this particular mass, go into its mass floors. Let's say we get rid of a few and hit OK. And then this one, we'll get rid of a few as well. And let's get rid of one over here. Or let's do two, that's fine. So we've made a design change. I'm going to save our work. And now let's head back to Dynamo. And since we have this set to manual, all we need to do is click Run. We can also set it to automatic, and it will automatically do the work for us. So I'm going to switch this to automatic, and it'll say Run Started, and it'll say Run Complete, which means that the file masterplan_data has been changed. Let's head back to Excel. Close this file, head back to Dynamo, switch this back to manual, run it again, force it to remake the file, switch it back to automatic so that it's running again just to be safe. It's ran it twice. Now if we head to Excel, we're going to go ahead and open up the main source Excel file that was created from the changed Revit model. You can see the information is displayed here, and some data has been updated and changed, as you can see. I'm going to close this file, and now that we're here back in the Excel file that's our dashboard, how do we go about and refresh the data? If I head over to the Data tab of the ribbon, there is a Refresh All command that we can click, and it will update the data for us, and our information changes. So the last thing in the dashboard that we want to look at for information is, for example, here under Total by Usage, you can see that that data is displaying here, and it's listing all the information that's checked. So if, for example, I uncheck residential and office and hit OK, that information gets updated to just display that data. If I click this icon here to get rid of any filters for this particular pie chart, that information shows all the data. Again, we can click in here, we can say, well, I really only need to see education and office, and hit OK. Now that data is being displayed, but it's also being displayed across all the buildings. What if we only wanted to display the data off of particular buildings like that? Now you have less data. And then also by level. So let's say, for example, we uncheck a whole bunch of levels. Our data is going to update. So this is how we go through the process of using Revit and Dynamo and Excel to create a digital dashboard. Thank you very much for watching, and let's head back to the PowerPoint presentation to wrap up. So now that we've gone through the demonstration on how to create a digital dashboard using Revit, Dynamo, and Excel, I'd like to wrap up our presentation by obviously letting you know that we are here to help you in any of your needs in regards to not just Autodesk training, software, and any other additional information on this particular webinar subject matter, but uh, Repro Products is a very diversified company, and we have so many departments that do so many different various roles and functions in the AEC industry and helping our clients. If you need any further information, please contact Repro Products at the address and the phone number you see on your screen. Thank you very much for watching the presentation, and I hope you enjoyed it.